All right, welcome. Today, we're going to put on our detective hats and solve some of the biggest mysteries out there, public health mysteries. We're diving into the toolkit that health professionals use to track down diseases and, keep all of us safe. I mean, have you ever wondered about this stuff? Why does the flu seem to just hammer one town but leave the next one alone? Or how on earth do scientists figure out that a specific batch of lettuce from one farm is making people sick across the country? These aren't just random chances. They're puzzles, and they have answers. And the key to cracking these puzzles is a really powerful, structured way of thinking. It's called the epidemiological approach, and it's basically the detective's manual for public health. So what does that actually mean? Well, put simply, it's a step-by-step method. It's about counting things, comparing different groups, and really digging in to understand the patterns. Who gets sick and why? It's all about using hard data to make smart decisions that protect entire populations. Okay, so let's get into it. Every good investigation follows a process, and this one has 4 main stages. First, you survey the scene. Then you connect the dots. After that, you have to prove your case. And finally, you take action and see if it worked. It's a really logical flow. So first up, step 1, surveying the scene. Think about a detective arriving at a crime scene. What's the first thing they do? They gather the basic facts. In public health, this is called descriptive epidemiology, and it's about getting a lay of the land. And it all boils down to these 3 simple but crucial questions. Who is getting sick? Is it kids? The elderly? Everyone? Where is it happening? Is it one neighborhood? One building? And when did it start? Tracking the timeline is absolutely key. These 3 questions give you your first big clues. Okay, so once you have those basic facts, you move on to the next step, connecting the dots. This is where you start looking for patterns and asking that really big question, why? This is the whole point of what we call analytical epidemiology. This slide just nails the difference. Descriptive epi tells you what is going on, but analytical epi is what lets you compare groups to figure out why it's going on. It's the leap from just describing the problem to actually trying to find its cause. And the main goal here is to form a hypothesis. Now that's just a fancy word for your educated guests. It's your theory about the culprit. Based on the patterns you found, you can say, I think this is what's causing the problem. And that hypothesis gives your entire investigation a sharp focus. But a guess isn't enough, right? Any good detective knows that. And that brings us to step 3, proving the case. Now you have to test your hypothesis and make sure the connection you found isn't just some random coincidence. You need real, hard evidence. I really love this because it gets to the heart of how science works. An idea is just an idea until you can prove it. This is where you move from just having a suspicion to building a rock-solid case. So, how do you prove it? Well, these are some of the main tools in the toolkit. You've got randomized control trials, or RCTs, which are the gold standard for testing if a new drug or vaccine works. Then you have cohort studies, where you follow groups of people over time, and case control studies, which are amazing for outbreaks because you start with the people who are sick and work backward to find the source. So, you've identified the culprit. You've proven the link. Case closed? Not quite. The whole point of this investigation is to actually do something about it. And that is step 4, taking action. And as you can see, it's not just a single action, it's a loop. You implement some kind of intervention. You recommend a policy, you start a health campaign. Then you have to monitor the data and evaluate. Did it work? You have to assess the impact. It's a continuous cycle of improvement. Because ultimately, all 4 of these steps, surveying, analyzing, proving, and acting, they all serve one single, incredibly important goal. It's all about protecting and improving the health of, well, all of us. Now, of course, the world of public health is always evolving. That 4-step process is still the foundation. But today's health detectives have some unbelievably sophisticated tools that are pushing the frontiers of what we can even understand. For instance, we now have advanced computer models that can simulate how a disease might spread through a city, which helps us get ahead of outbreaks. By analyzing these huge data sets with millions of data points, we can spot tiny patterns that were totally invisible before. These new tools are making investigations faster and way more precise. So there you have it, the epidemiological approach. It's really more than just a method. It's a mindset. It's a powerful, logical process for taking messy, confusing data and turning it into clear, decisive, and often life-saving action. And that leaves me with a final thought for you. If this systematic way of defining a problem, gathering evidence, developing a theory, and testing a solution works so well for huge public health challenges, where else could we apply this same way of thinking?
Hey, if you found this helpful, do us a favor and hit that like button. Let us know your biggest takeaway in the comments, and of course, subscribe so you don't miss what's coming next.
And by the way, if you'd rather just listen, you can find the audio-only version of this on Apple Podcasts. We've dropped a link for you right in the description. And finally, we really want to hear from you. What topics should we investigate next? Let us know in the comments below. We read everything, and your feedback really does shape the show. Thanks so much for watching, and we'll see you in the next one.